Today we are looking at quadratic number patterns. Quadratic number patterns. So a quadratic number pattern is a general term of the form Tn is equal to a n squared plus bn plus c. So a quadratic pattern is a general term of the form Tn is equal to an squared plus bn plus c. All right, where a is not equal to 0. Where a is not equal to 0. Where a is not equal to 0. All right, so a quadratic number pattern has got the first difference row, 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 and it has got second difference row. Second difference row. Right. Okay. So there are three rules or three concepts that you need in order to find the general term. In order to find the general term of a quadratic pattern. So what are the rules or the concepts? All right, so let me just write here and say rules. I'm going to explain them later, but in the meantime, I'm just going to first write them down. Okay, so the first one is 2a. All right, let me start with the first one, which is a plus b plus c. All right, a plus b plus c. And then we have 3a plus b. And then we have 2a. Okay? All right. So let's look at an example of a quadratic pattern, and then we apply these rules and come up with our general term. Okay, so I'm going to write this quadratic number pattern. 2, 5, 10, 17, 26. Okay, so you can see that this quadratic number pattern is going to have a first difference row. First difference row. Okay, so a quadratic number pattern does not have a constant first difference. It's gonna have the first difference row and the second difference row. Okay, so here the difference here is gonna be 3. Then the difference here is gonna be 5. The difference here is gonna be 7. The difference here is going to be 9. It's going to be 9. So this will be our first difference row. As you can see, this will be our first difference row. That's going to be our first difference row. Then our second difference row is going to be having 2, as you can see there. It's having 2. So this will be our second difference row. Okay, so now we are going to apply our rules, okay? So the first term here of a quadratic number pattern, which I am circling there in red, we get it by applying that first rule that I gave you, which is A plus B plus C. So A plus B plus C is equal to the first term of the quadratic number pattern. Okay, now we are going to touch on the next one, the next rule, which is 3A plus B. So 3A plus B is equal to this second, the first term of the first difference row. I'll repeat. The 3A plus B is equal to the first term of the first difference row. Okay, so 3A plus B is equal to this. Okay, then 2A is equal to the first term of the second difference row. All right. I hope this has been understood. So this 2A is equal to the first term of the second row. Okay. So if I apply these rules, A, B plus C, and 3A plus B, and 2A, I'll be able to get the values of my A, and then the values of my B, and then my value of my C, which I will then sub in to the general term of the quadratic number pattern, which is Tn is equal to An squared plus Bn plus C. Okay, so these rules, they will help me to find the values of A, B, C, which I will then sub into this general term of the quadratic number pattern. All right, without wasting time, I'm going to write again that quadratic number pattern. And we are going to apply everything that we have just touched to find the general term. All right. So I'm going to write again 2, 5, 10, 17, 26. This was our quadratic number pattern. All right. So the first difference row was 3, here, 5, 7, and 9. Then the second difference row at 2 here, 2 there, and 2 over there. Okay, so what do I need to do first? I need to find my A. I need to find my A. Remember I said 2A is equal to what? To this first term is equal to the first term of the second row. Okay, first term of the second difference row. So what I'm gonna do is I'll take this 2A and I'm gonna create an equation here in order to solve for my A. So 2A is equal to 2, then divide here by 2, divide there by 2. These cancel out. 2 into 2 is 1. Therefore, A is equal to 1. So I've already found my A. The next thing that I'm going to do that now I found my A, I'm going to use the other rule, which is 3A plus B. Okay, 3A plus B. So remember we touched on the fact that 3A plus B is equal to the first term of the first difference row. So 3A plus B is going to be equal to 3. I've created an equation and we already have found the value of A, which is 1. So where there's A, I'm going to sub in and I'm going to put 1 like this. And now I can solve for B. All right, so 3 times 1 is 3. So this becomes 3 plus B is equal to 3. Then I take this 3 to the other side where it's going to be subtracted. So you can see that B is going to be equal to 3 minus 3, which is 0. So B is equal to 0. So I found my B. So now I can find my C by substituting my value of A and my value of B. Okay, so which rule am I going to use? Now I can use A plus B plus C. All right, and we did say that A plus B plus C is equal to the first term of the quadratic number pattern. All right, so A plus B plus C is equal to 2 in our case here. So I come here and then I write A plus B is equal to 2. Then I'm going to substitute the value of A and the value of B in order to find C. So A was 1 there. I'm going to put 1 plus B is 0. And then I'm going to put 0 plus C is equal to 2. All right. So this will be 1 plus C is equal to 2. Then take this 1 to the other side. So C is equal to 2 minus 1. Therefore, C is equal to 1. C is equal to 1. So I have my A, which is equal to 1. I have my B, which is equal to 0. I have my C, which is equal to 1. So what am I going to do now? I'm now going to substitute the values of A, B, and C into the general term of the form T n is equal to an squared plus bn plus c. So this is the general form of a quadratic number pattern. So I'm just subbing in the value of A, B, C into this general term form. Okay. So this will become Tn is equal to A is 1. A is 1. A is 1. So I would write it as 1n squared, but mathematically, we don't need to write 1n squared, but I'm just going to write 1 so that you see that there is a 1. I put a 1. See, there's no need for us to write that 1 anyway. Just leave it as n squared, but I'm just going to put it there for you to understand. Okay. So I've put 1 in the place of A there. All right, then plus Bn. So Bn means B times N. Means B times N. And then my B is 0. All right. Times N. That's what it means there. All right. Then plus C is 1 here. So I'm then gonna put 1 here. Okay, let me simplify. So this will be Tn is equal to n squared. Now I'm just writing it as n squared. I'm not gonna write the 1 or put the 1 there. So n squared, 0 times n is 0. So I'll be left with n squared plus 1. So this is the general term or the nth term of the quadratic number pattern 2, 5, 10, 17, 26, and 37. All right, let's look at another example. Let's look at another example. Consider the following number pattern 6, 17, 34, 57. And I'm just gonna put ellipsis there. So as you can see, this is a quadratic number pattern. So what it means is that I'm going to have my first difference row, then my second difference row. So let's start with the first difference row. Here, the difference between 17 and 6 is 11. Here, the difference between 34 and 17 is 17. The difference between 34 and 57 there. Oh, okay, let me just continue with it then. It's fine. Let me just add maybe 2 more numbers, okay? So let me add 2 more numbers. So I'm just gonna put 86, then I'm going to put 121. Okay, so the difference between 34 and 57 is 23. The difference between 57 and 86 is 29. The difference between 86 and 121 is 35. So this is our first difference row. All right, so now I'm going to the second difference row. The second difference row. The second difference row, you can see that the second difference row is 6, 6, 6, 6. All right, perfect. Perfect, perfect, perfect. So what do I now need to do is I need to find the nth term, all right? I need to find the nth term. So I'm going to apply all those concepts that we touched on to find the nth term. Okay, so what am I going to do? First, I'm going to take the first rule of 2a. is equal to the first um, term of the second difference row, which is 6. So 2a is going to be equal to 6. So 2a is equal to 6. Then I solve for a. Divide here by 2, here by 2. So you can actually see here that a is going to be equal to 3. So I found my a. Okay, so for me to find my b, I'm going to use 3a plus b. That rule of 3a plus b. 3a plus b, which is equal to the first term of the first difference row. Okay, so 3a plus b is equal to 11. Is equal to 11, this 11 over here. All right, so we have already found our a. So in the place of a, I'm just going to put 3. All right, so here it's gonna be 3. Then where there's a, I'm going to put 3. Then plus b is equal to 11. 3 times 3 is 9. So 9 plus b is equal to 11. Then I'm going to take this 9 to the other side. Here I'm going left with b is equal to 11 minus 9. Therefore, b is going to be equal to 2. So I found my b. Okay, so now I need to find my c. All right, and I'm going to use the rule a plus b plus c, which is equal to the first term of the quadratic number pattern. Okay, so then come here, then write a plus b plus c is equal to 6. Then where there's a, I'm gonna put 3 since we have already found our a. Then where there is b, I'm going to put 2 since we have already found our b. Then plus c is equal to 6. Then 3 plus 2 is 5, so that will be 5 plus c is equal to 6. Then take this 5 to the other side. So therefore, c is equal to 6 minus 5. Therefore, c is equal to 1. So as you can see, and now we have my a, I have my b, and I have my c. The next thing that I'm going to do is to write down the general term form, of the quadratic number pattern, which is Tn is equal to an squared plus bn plus c. So I'm just going to substitute the values of a, values of b, the values of c into this general term form. So this is going to be equal to, where there's a, I'll put 3. So this will be 3n squared plus Where there is b, I'm going to put 2. So this will be 2n plus where there is c, I'm going to put 1. So this is what I have now. 3n squared plus 3n squared plus 2n plus 1. So this becomes the nth term rule. This becomes the nth term of 6, 17, 34, 57, 86, and 121. So that's how you basically do in order to find the nth term of a quadratic number pattern. All right. Cheers. Bye-bye.